Bismillahirrahmanirrahim. Assalamualaikum and good day. I'm covering on the second part of the list, which is covering on the first part was covering on array. The second part will be covering on linked list and also vector, and how you go about traversing the list. When I say traverse, it actually means that you want to check the element in the list one by one from start to end. Okay, that is what it means by traversing. Okay, coming back to this diagram again, I have mentioned to you just now, list is actually under collection. Right, underneath it there is vector, array list and linked list. So I'll be covering on linked list. Okay. Is if you can still remember the way when we represent array, it's more like a list of table, right? So we try to add an element inside the table. But when we are talking about linked list, it looks like a chain of nodes. Okay, this is called nodes, right? So it's actually a list. It's just that this list is not in a table kind of manner that when you use an array. Okay, you can imagine it looks like a chain of nodes whereby each node, so this is called a node, it will contain an element. Okay, you can put a string or integer inside it, or you can put an object inside it, and other than the element it has another attribute which is called next. Okay, next will be the chain to the next node. It will store the reference to its next neighbor. So this one here is actually pointing to the next node, which is the neighbor. And this is actually storing the reference. It will be now if this is the last node in the sequence. Let's say this is the last node in the sequence. So this next will point to now. Okay, normally if you use a linked list, there is an additional reference that you use, which will point to the front and point to the back. Okay, so that you can move from front to the back. Okay, you need to be careful with linked list, because if you along the way when you add or you remove, you do not handle the next attributes carefully, you might be referencing to a node which is not the correct one, or maybe the item behind it will be lost. Okay, so maybe we can take a look later. Alright, the good thing about using linked list is that the chain or the list can grow as large as necessary. Okay, because you can add it as you like. And you can add and remove without shifting the existing entry, like the one that we see in the array list and also in the array. When you want to add in the middle, especially, you have to shift the elements after it to the back. So all the elements will be shifted, will be shifted to the back, and the index will be increased for each of the elements. The same goes when you want to delete. When you want to delete in the array list, so you will have to shift all the element after it to the front. So you have to increase the index for all of the element. I hope that you can still remember that. Okay, that's the good thing about using linked list. The disadvantage of using linked list is that you must traverse the chain to determine where to make the deletion. So you have to check from front. You have to check one by one. Okay, because it's a chain, so you need to go check one by one from the front before you make any deletion or adding. And you retrieve an entry requires traversal. Okay, so this is what it means. But if you want to use array or array list just now, you can go straight to the exact location or index. So if you see here in the linked list, there is no such thing as index. So you need to traverse it. You need to check one by one because there is a next attribute, yeah, that will point to the next neighbor. Right. So this is how you can imagine the linked list look like. Okay, it's like a chain. So this is a node whereby when you have a you have a linked list, you normally maintain this attribute which is called first node and the last node. Okay, let's say you want to add X, so it will add it at the end. Okay, and then what you need to do is that you have the last node. This last node, because it's the last node, it will the next will point to now. But if you want to add something at the end, so the next for the last node will point to the new node. So later on, this last node will be assigned to here. Okay. So let's say you want to add index X. You want to add X at certain index, maybe in the middle of the list. So what will happen is that, so this is the list. Okay. Let's say in this example, you want to add the X at index 1. Okay, so this is the new node that you are trying to add. So what will happen? Oh, okay, sorry. In this example, not index 1, but index 0, 1, 2, 2. Okay, so at this, so you need to traverse it. Okay, because when you use linked list, you need to check from front to the location that you want. Okay, let's say you want to add it at index 2, so it will, after index 2, this next will not pointing to the neighbor, but will point it to the new node. So this new node next attribute will point it to the next neighbor. So that's how it is being added. So if you do not manage this properly, maybe this linked list will be lost, especially if you do not maintain this variable node after. Okay, so if you do not handle it properly, so it will be lost. Alright, the same goes with remove. So this example is showing remove the first element. So originally it's like this. Let's say you want to remove this first element. So this first node will next. Before this one is pointed by next for the first node. But what happened here? The first node will point straight away to the first index node. Alright. So this is showing you visually how the linked list handle remove in the middle. Okay. Let's say you need to traverse it and you find what are the nodes that you want to remove. Okay, so let's say you want to remove this. You need to assign a variable to point to this node that you want to remove. Okay, and after that, okay, the 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 variable here that point to the node before. Okay, the node before dot next will point it to the node after. So it is like it is no longer, it will skip this node and point it to the one after. So that is what linked list is. So you can add it where you like. You don't have to shift it, but you need to be very careful to handle the next attribute. Okay, so that you do not so that you point it to the right nodes rather than pointing to a node which is at the wrong location. Alright, how do you declare linked list in Java? It's like array list, it's just that this one use linked list. So whatever here is the kind of data that will be in the linked list. If you want to put an integer object, put integer. If you want to put a string, and so on, you can put objects also. So how to make sure that you get it right? So if you put linked list integer, you put the name and then you put new. You repeat back linked list integer and then you add the bracket here. So that's how you define it. Right, I have mentioned to you because we use array list um, or linked list, you need to be able to traverse it. You need to check from front to end. Okay, you need to able to iterate over or traverse a collection. You want to check one by one from front. So how do you use it? You use Iterator. It is actually an interface in Java util. So if you want to use Iterator, you need to import java.util. And inside this Iterator, there are only three methods. Next will check the next index. Okay. Hashnext will check whether is there any an index after it. Okay, next we'll move to the next one. You can remove it. There's a method called remove. Right, to get the iterator object, you need to use iterator methods. How it looks like. Okay, this is how you can declare it. Okay, for example, you have an array list. For example, the name is student list. And then you do dot iterator, so you use an iterator method. So when you do this, you actually will get an iterator object already, so you assign it to a variable called whatever. So this is a variable name and the type is iterator. Okay, so this one will be the array list that you want to check. Okay, and then this is only the name of the variable and the type is iterator. So iterator is the interface that I've mentioned to you just now. Okay, let's say in this example, okay, our array list that we want to check is actually student list, and you do dot iterator, so it will return to you an iterator. So this is the name of the variable. And then it's up to you. You can use for loop or while loop. So let's say in this example, you use a while loop. It says here while list iterator dot hashnext. It says here if traverse the list until it reach the end. Okay, it says list iterator dot hashnext. Do this if it does not return false. If there is no, if it reach the end of the list, hashnext will be false. Okay, if so this is basically how you check whether you have reached the end of the list or not. Okay? If you do not reach at the end of the list, so you keep on looping. So it will check from front. Okay, so this is dot iterator. So when you do dot iterator, you actually you allow the list to be traversed. Okay, so it will check from the front. So when you use dot next, you actually check uh, print system.printout system.out.println list iterator.next. So it will check this first element first, and then it will go check again. Is hashnext is it still true? If it's still true, it will do this. It will check the next element, and it will go and on checking until hashnext is false. When hashnext is false, so it means it's already reaching at the end of the list. Right, you can either use that way or you can use using for loop. Okay, with for loop, what you need to do is this is the name of your iterator. Element, you can use element x, y, and so on. Object will be the type of element. For example, in the list, um, I believe this is the iterator already. Let's say you have a list. In that list, you store only string. Okay, so object here refers to string. Let's say you have a list where you have student objects. So object here will be student. So element, you can put element S, Y, Z, and so on. Right? So this is basically another way of traversing the list but using for loop. Okay, so with JDK 1.5, this is the way that you put it. Alright, it's more like a short form kind of code. So we are going to look at an example. This example creates an array list with a specified capacity and insert element in the specified location and try to remove, and then we'll take a look how iterator has been used. Okay, this is an array list integer. Inside it, they want to put integer object. Okay, and the name of the array list is a list equal new, okay, array list integer, and then don't forget to put this. You can put space in between, no problem. Right, so you have declare the object of array list. The name type is a list, and then you keep on adding 1, 2, 3, 4. If you do like this, it will add at the end. So I believe there is 1, 2, 3, 1, and then it wants to add index 0, 10. So before this one is index 0, yeah. Now you want to put 10 on top. So what will happen? It will shift all this down. Okay. And then at index 3, you want to put 30, 0, 1, 2, 3. 0, 1, 2, 3. So it want to put here at 30, it want to insert 30 here. Oh, sorry. I don't write it well. Right. So the new list will be 0, 10, 1, 2, 30, 3, 1. So now here you want to add, you have done this set for 40. So 0, 1, 2, 3, 4. So you want to add here 40. So the new list will look like this. So 3 and 1 will be shifted down. And then it says here remove 1, 0, 1. So the new list will be 10. 1 will be removed, yeah. 2, 30. Sorry for the bad handwriting. 3, 1. So this is the latest one. Okay. And then, because you want to go and check what is in the array list, so you do a list. Why? Because we define your array list like this. Dot iterator. So you will assign it to a variable. Okay. And the type is iterator. So if you use a while loop, this is how you put it. List iterator.hashNext, and then it will do list iterator.next, and you want to print whatever inside it. So it will be 10 to 30, 41. I'm sorry, where is our 3? 1, 2, 3, 1. And then you add 10, like this. And then you add 3. So you add it here. I think there's a missing 3 here. Okay. We never. Okay, should be 3 here. Okay. So this is how you do it if you use while loop. Okay. You can also add an object. Okay, the one that you have seen just now is integer object. This is a student object. For example, you want to have an array list where you want to put students object inside it. So you can either do like this, add new student, or you create the object first and then add it there. So if you want to use traversing uses for loop, okay, here you put the name of the, okay, here you put the name of the array list. Okay, so it will convert, it will allow you to traverse. And then S, it can be S, X, Y, and Z. This one will be the type of object inside the array list. So you can say in here you can system.out.println s dot get something. Okay, you want to access the data of the student one at a time, right? Or you can use toString method. All right. Let's look at an example using linked list. Okay, that one just now is array list. This is linked list. Okay, linked list string, meaning that in this list you want to put string inside. This is the name of our linked list, right? New linked list. Don't forget this, right? And then you keep on adding red. Okay, red, and then red is the first item. Okay, and then you add green at the first location, so you have green, red right now, and then you put blue, so blue will be the third element there, and then you put at location index 1 you put yellow. So just now you have what? Green, red, blue. Yeah, so right now will be green, yellow, red, blue. Okay, and then you want to remove something, and what to remove? Linked list size -1. Okay, so you, based on the size, you want to delete the second last item, right? So it will be you remove yellow, yeah. No, you remove blue. Okay, this one you remove blue, and then you use iterator. You convert it to an iterator. Okay, if you are using while loop, you need to convert it to the iterator first, and then iterator is next. So while the iterator does not reach at the end of the list, it will keep on looping, and then it will access each one of it. So it will be green, yellow, red. Okay, that's how that is what in the list. Okay, we have look at array list, linked list. The next one is vector. Okay, vector is similar to array list except that vector contains synchronized method for accessing and modifying vector. Okay, none of the new collection data structures introduced so far as synchronized. If you do not yet synchronize, use array list since it's faster than vector. What does synchronize means? Okay, let's say if you want to have a list, and this list will be accessed by many threads or many objects. So you don't want, maybe let's say you are adding something in a vector, you do not want another program to also add at the same index. Okay, so you do not want the data to be changes while it is being written at certain index. That is what it called by synchronize. Okay, so I think you'll be learning about this in real-time programming. If you are doing in that kind of situation, you use vector. Else, you simply use array list. Alright, when you use array list, it will increase 50% of the current array list. If the number of, so let's say the array list is about to be full, it will increase the size by 50%. For vector, if the size of list is about to be full, it will add 100% of the array size. Okay, so it will add up more size. Array list is faster because it does not deal with non-synchronized. So vectors on the other hand is slow. So when you want to iterate the array list, you use iterator. Whereby if you are using vector, you use enumeration interface to traverse the element. So it's actually the same, doing the same process. It's just that this one use a different interface. This one is iterator, like the one that we used before. If you are using vector, you need to use enumeration interface to traverse. Okay, vector is under list. All right. So it's also having the same operation like the one in array list with different, slightly different operation. You can add capacity, copy into, element add, elements, okay, return and emulation of the vector. It returns the elements, and then ensure capacity. This one increases the capacity of the vector. Get the first element, insert element, add. Okay, so this is like set. Last element, it will get the last element. Remove all elements. Remove all. Remove element. Remove the first matching element. Let's say there are many similar element. It will remove the first one. This one remove element at certain index. Set element, set the size of the vector. Trim to size. It will trim it. Let's say, because vector, when you want to add, it will add 100% the size, right? But maybe the data is not full, so it will trim the size. It will try to get the actual size of the vector. Okay, if you are using a vector, you need to declare it like this: vector. Maybe I put it vector 1 here. Okay, vector 1 equal new vector, right? When you do vector dot capacity, at this point of time, when you do like this, it will set the capacity to 10. So that this is the actual size, not the actual size. It will provide you the space for 10 to put 10 elements. Okay, when you do vector dot size, it's 0. Why 0? Because you do not put anything yet there, right? And then you keep on adding. So when you want to add something, you do add element 1, 2, 3. So if you see here, when you use vector, you don't have to specify the type, yeah, string or object like the one that you use in the array list. When you do array list, you need to do something like this, yeah, to specify the type. But for vector, you don't have to. You simply call vector, give the name and new vector. So even though you do not put anything yet, so vector already put a space, create a space for you. For example, in this case, it's 10. And then here you keep on adding, add 3 elements, 1, 2, 3. And then you want to add element 4, you want to add 1. So it will add 1, 2, 3, 1. And then and once you have added, you want to check what is the capacity. So the capacity is still 10 because it's not full yet, but the size is 4. Okay.